Okay, today we are solving bolted connections from board exam May 2016. Okay, the 2L 90 by 90 by 8 mm diagonal member with the area gross of 2700 mm squared at the left of the connection is shown is bolted to 8 mm thick gusset plate. So the given bolt diameter is 16 mm, bolt hole is 18 mm, and the allowable shear stress of bolt is 68 MPa. So there are other parameters given here like the yield strength of steel, which tensile strength. So this is a correction because uh, the type value here is for 80, no? Pero yung tama is 400 MPa. Okay, you have allowable tensile strength on gross and so on. Okay, so the figure is like this. So this is the figure. Okay, we have the distances given here, 35, 50, and 40, which signifies S1 to S3. I mean S1 to S4, spacing 4. Okay, we compute the first question. Calculate allowable load P based on shear capacity of the bolt. Okay, so when you tackle these kind of problems, you're asked with different modes of failures. Modes of failures, it could be uh, the bolt will fail, the plate will fail, the shearing of the members, and so on. Okay, so here, what is the force needed? P, so that uh, the bolt will fail. Okay, so basically, we know that stress we denotes F is equals to force over area. So when we solve for force, so force is equals to stress times the area. Okay, so what is the stress in the area? So the stress is given by the parameters here, which is 68 MPa. So force is equals to 68 MPa is Newton over millimeter squared. So the area here is the bolt area. So the area of bolts. So area of bolts is pi over 4 d squared, diameter squared. The diameter is 16. So 16 squared multiplied by how many bolts will be catching the load. So the number of bolts is 1, 2, 3. So you should multiply it by 3. Solving, so solving this, you have the force P. No? So the area will be in mm squared. So if you can cancel this, you are left with Newton unit. Okay, I had 41.0616. This is in kilonewton already. I divide it by 1000 so that I can convert it. So this is our answer. So 41 is close to 42. So the letter C is the answer. So that's answer. So basically what that means is when you apply 42 kilonewton force here, your 3 bolts will fail and this connection will fail. Okay. So 41, calculate the allowable load P based on bolt bearing stress. Okay, so another way of failure is the bolt bearing stress. No? So basically what will happen is the bolt hole will elongate, no? Over the force P, the bolt hole will elongate here. So that is what we call the bearing failure. No? Okay, so basically your hole will elongate due to the force P applied going in that direction, and then your connection will fail. No? Bearing stress. Yes. Okay, so with this, we are given with shear stress. So same formula. So P or force is equals to stress bearing times the of area of the hole. No? Area of the hole. So force bearing is denoted as 1.2 FU. So we multiply. FU is 400. This is 480. 480 MPa. And the area of the hole is so this is the bolt hole diameter, no? 18 mm. So basically this is pi over 4 times 18 squared times the number of hole, which is 3, equals to 243 pi mm squared. I know, we made a mistake. No? So the area, which is not the area of the hole, no? Area of contact in the hole. Area of contact of the hole. So basically this times the thickness. So this is 16, I mean 18. I know, we use 16. So the contact area is 16. So basically if we will draw that larger, this is the figure. No? So you have the hole there. No? And then you have the bolt. Sorry, it's not straight. No? And then this is pulled, the force P. So the contact here at the back. No? The portion that will elongate. Okay. So the area is bolt hole, which is 16, multiplied by the thickness times the number of contact. So this is 348. I mean 384. 84 mm squared. So you're ready to substitute to find the force P. It's equal to 480 Newton over millimeter squared times 384 m squared. You can solve here is in Newton. So that's 480 times 384. So that's 184.32. That's in kilonewton now. So we look at the choices. If we have the answer 184.32, that's letter C. Okay, so we are now solving for number 42. Calculate the allowable load P based on block shear of the double angle. Okay, so the failure will be like this. So this will tear up, no? This area, and then this area also. So this area will be removed due to the force P. Okay, so how do we solve that? So basically you have two kind of stress here. So the first is here, the portion here will experience the stress of tensile, and here will experience the stress of shear. Okay, so we have different areas and different modes of failure. So that's block shear. That's what we call block shear. Okay, so number 42, just erase that. 42. So the force P is just the summation of the failure modes. So you will fail at shear and tension. So you will have stress at tension multiplied by area experiencing tension plus stress of shearing times the area experienced shearing. No? So here we have the formula for shear stress, which is 0.3 Fu, and tensile stress. That's stress, not stand. Stress on net area, so 0.5 Fu. Okay. So stress tension is equals to 0.3 Fu. So Fu is, I think, 200. 400. Okay. 400. 0.3 times 400. Okay. We have stress and tension. So the stress and shearing is equals to 0.5 of Fu, which is times 400. So this is 1/2, so this is 200 MPa, 120 MPa. Okay, so problem of the missing is area experiencing tension and area experiencing shear. So area in tension is just equals to length net, the length net multiplied by thickness. So the length net here is, so what will be sheared is just this portion. This minus by the bolt diameter 1/2 of the bolt. So this is S4, and then this is diameter over 2. Okay, so that's your length net. So that's S4. Yeah. Okay, so S4 is 40 mm. It's just equals to 40 minus 0.5 of the bolt diameter, which is 18, multiplied by thickness of 8. No? And then times 2 also, because the member is two leg. Okay, that's 2 leg back to back. So basically, if that's the L member, you have another L member there welded here. So that's your member cross section. Okay, so you should multiply it by 2. Okay, we have 40 minus 9 times 8 times 2 is 496. 496 mm squared. So you have the area in shear is also length net times thickness times how many. So we should not write how many. So basically that's okay. We should inspect. Okay. So so the length is this minus the whole. No, you should minus the whole, one whole, two whole, and then 1/2 of a whole. So that's okay. So that's S3 plus S2 plus S1 minus, say, 1, 2, 2.5. 2.5 of the diameter of hole. So okay, so S3, S2, and S1 minus 2 diameter. So S3 is 35. I mean S2 and S3 is both 50 mm and S1 is 35. Okay, so we write it here. 50 mm. 50 plus 50 plus 35 minus 2.5 of 18. So that's the bolt hole times 8 times 2. So you have the area now. So you have 11440 mm squared. So substitute area intention is 496. A plus for stress and shear 120 times 1440. Okay. Okay, we have 272 kilonewtons. Okay. So we're checking 272 is in letter A. Okay. So that's how you solve for block shear. Yes, block shear and bolted connections.